Okay, so to begin, I'll go ahead and underline what's given. Okay, and also note that we're given our measurements at STP, and STP is 1 ATM and 273 Kelvin. And we also have 0.258 liters because 258 milliliters is equivalent to 0.258 liters. And then we have 0.646 grams. And I think from all the information that we've been given, that this is going to be a PV equals nRT problem. And we're actually going to change this a bit. So then M is mass, and then this M down here is molar mass. And the way that I derive that is that the molar mass is equal to grams over mole. And you just switch mole and molar mass. And moles is what N represents. And then grams is mass. And then you have molar mass down here. So that's how you get from N to mass over molar mass. And we're going to need to turn carbon and hydrogen into moles. And it gives us a percentage, but we're able to turn it into moles regardless. Because when a problem gives you a percentage, and it's out of 100, you can turn this into grams. And I'll show you what I mean by that. It's that simple. And I'll go ahead and convert it to moles using stoichiometry. So carbon has a molar mass of 12 grams per mole. Right. And that will give me 7.14 moles. And I'll go ahead and do the same for hydrogen. And that will give me 14.26 moles. Okay, so now we have our moles. And the next step is going to be let's go ahead and find our empirical formula based on this information. So I'm going to go ahead and write carbon with the subscript of 7.14. And hydrogen as well with the subscript of 14.26. Divide both by 7.14. That will give me carbon H2. So this is our empirical formula. Okay, so to find the molecular formula, we're going to be multiplying our empirical formula by a number, and that will give us the molecular formula. But to find that number, we're going to need to use PV equals nRT. So let's go ahead and plug in our values. So pressure, it's going to be 1 atm since at STP, pressure is 1 atm. Volume, they tell us that it is 0.258 liters. Mass, they give us point. Oh, actually, yeah. Okay, yeah, we can plug in our mass. And then since we're solving for the molar mass, that's our unknown variable. Then R is a constant. It's 0.08206 liters times ATM over mole times Kelvin. Temperature, it's given STP, so that means 273 Kelvin. And now we just use our calculator and plug everything in, but I'll go ahead and cancel the units out. So that leaves us with grams over moles, which is the correct units for molar mass. So once I'll go ahead and do a step real quickly. Is equal to 646. I'm not solving it. I'm just rearranging the equation to isolate the molar mass. So once you plug in everything and solve, you're going to get 56.1 grams per mole. So with this number, we can go ahead and find what the molar mass of the empirical formula is. So if the empirical formula is just CH2, if you add 12 plus 2 together, that will give you 14. And then next step would be divide the molar mass that you found. 56 divided by 14, giving us 4. So now we can go ahead and multiply the empirical formula by 4. Giving us C4H8. And then that right there is our molecular formula. All right, guys, thank you for watching. I hope you enjoyed.